Hello students, welcome to the part 2 of circular motion video. So let's start with the third question. We did these two above before. So remember the dimensional analysis approach. That's the best way to reach the solve these problems. So we have the question here, a CD with a diameter of 120 millimeters rotates at a rate of 45 revolutions per minute. So first of all, now he has given the diameter. See, that's what I was talking about in the previous video. So he has given the diameter, that means twice of R is already 120. Okay, so keep that in mind as we see this. So we are starting with 120 millimeters and 45 revolutions per minute. So let's start there. So our goal is to get the linear speed in millimeters per minute. So this is the goal. The goal is millimeters per minute. Okay, and we are starting with 45 revolutions per minute. 45 revolutions per minute. Because per minute it's already done, we don't have to worry about converting minutes into hours or seconds. It's all done deal. But revolutions should be changed. So that means we have to cancel out this revolutions, meaning you have to say one revolution is how many millimeters or inches. In this case, we are starting with, no, actually it's even more simple. It's 120 millimeters at this end. So we just have to do 2 pi, actually no, just pi times, because now, because 2r is taken, 2 pi r is now just directly 120 pi. Okay, so that's it. So 120 pi millimeters. Don't forget to write that, because that's how we have to process this. So you just have to cancel the revolutions in the units and you'll be ending up with millimeters per minute, and you have to multiply 45 times 120 and pi. Okay, so you will do that with the calculator and you should be getting 16964. Remember, in Math Excel, don't try to put commas. Okay, now millimeters per minute. Okay, so that's the answer for this. So let's quickly try the next one. Now he's saying angular speed. So we are starting with 45 revolutions per minute, just like so. And the goal should be radians per minute. The goal should be radians per minute. So times, so one revolution is 2 pi radians. That's it. Okay, there is no r here, just simply 2 pi radians. This r is part of the word radians. Okay, so that's it. So you really don't have to do much here because it's already in minutes. So 45 times 2 pi would give you the answer, which should be 282.7 radians per minute. Okay, now the next one is where you have to be careful. Now this has a lot of conversions going on. So a 16-inch diameter, you want to highlight some important things. 16-inch diameter is making 500 revolutions per minute. Find the linear speed in miles per hour. So here it is given in inches. You have to get this in miles. And also there are per minutes and you have to change it into hours. So that's the thing. So let's look at this carefully. So the goal is miles per hour. Okay. And now what we are given is 500 revolutions per minute. Okay. Times. Now the minutes should be converted into hours. So the minutes should be cancelled to hours. So meaning you have to bring in the minute in the numerator to cancel out the one here in the denominator. So 60 minutes is 1 hour, isn't it? 1 hour. 60 minutes is 1 hour. so that the minutes and minutes will cancel off. So that's the idea. Okay, we are not done though. We have to take care of the revolutions. So the revolutions here is in the numerator. So that means you have to bring revolutions in the denominator as a conversion factor. So revolution, REV, is 2 pi r radians, right? Again, here he is giving diameter. So which means 2 pi r is actually 16 pi, because 2 times r is already 16, because he has given the diameter, not the radius. So here we have 16 pi inches. Okay. Now this inch should be again cancelled out because inches should be converted into miles. So that should go into the denominator. But how many inches makes a foot? You have to first convert it into foot and then to miles, right? Because the goal is miles, not even foot. So 12 inches makes 1 foot, right? Okay, so with that the inches would cancel, the revolutions will cancel, but again 1 foot should be converted into, this foot should be, the feet should be converted into miles. So how many feet makes a mile? So you should get the feet in the denominator and get miles here, right? That's the goal. But how many feet make a mile? So that's the conversion. How many feet? It happens to be 5280. This is something that you could remember. 5280 gives 1 mile. You see how many conversions are going on here? This is dimensional analysis. Even in chemistry, you would do the same thing. So now the feet will be cancelled, right? Now all we are left with is, if you see only the units, I'm just saying the units. In the units, you are just left with, in the numerator, miles, and in the denominator, just the hours. And that's what we want. That's the goal. Okay, now let's come to the numbers. 500 times 60 times 16 pi, all divided by 1 hour and 12. So you have to be careful when you're doing the calculator. So I'm going to change the Windows size so that you can see the calculator. Okay, switch it on. 500 times 60 times 16 times pi. Pi is here. Okay, first let's look at that, what it is. So this is a big number, but here in the denominator you have 2 numbers to divide. So don't do divided by 12 times 5280. That's a mistake that people do. So divided by 12, do it separately, or do divided by twice in the same thing. So divided by, answer divided by 5280. 5280. Okay, 0. It's not, okay, 0. There you go. Okay, so you get 23.79. We can round it off to the tens place. You just do what it is according to the Math Excel's rounding off. So to 23.80 miles per hour. Okay, so it's all step by step. You have to be really careful with the units. All right, so let's do one more question. Okay, a circular saw blade with dia 9 inches. So immediately, which means 2 times r is 9. So 2 pi r, meaning 9 pi. Okay, keep that in mind. And oh, he wants angular speed. So we really don't have to do this. We really don't have to do this because he's asking for angular speed. And the diameter is giving in 9 inches. It doesn't have to, we don't really have to use this. But look at 2800 revolutions per minute, and he wants the answer in radians per second. So the goal is, radians per second. The goal is radians per second. Okay, per second. Okay, so look at this. Now 2800 revolutions per minute. Revolutions per minute. So how many minutes make a second? So the minutes should be cancelled off. So that means minutes will go into the numerator. So 60 minutes make, sorry, my bad. 1 minute, not 60 minutes. Oopsies, Miss Madhavi. 60 minutes, sorry, 1 minute makes 60 seconds, right? And then now, so minutes will cancel off, but we have to take care of the revolutions now because we want in radians per second. So revolutions, that means revolutions must be in the denominator. One revolution is 2 pi radians. That's it. One revolution is 2 pi radians. So this revolution will cancel off. So your final answer would be 2800 times 2 pi divided by 60. So let's do that. 2800 divided times 2 times pi divided by 60. There is only 1 divided by, luckily. So that is 293.22. Let's do that. 293.22 radians per second. Okay, that's how you do it. And the key for this packet is already there, but I just want to mention to you that the next part, the next half, you don't have to worry about this because we are doing dimensional analysis anyways. Okay, you don't have to convert all of this. If you simply do the dimensional analysis with the units, you will be really in a good place. Okay, so please look at my review key for your answers. I want you to try them. Okay, thank you for watching. I'll see you next time. See you.